Welcome to Techstination. Joining us is Alexandre Kaspar, a student and lead researcher on a very interesting project at MIT's Computer Science and Artificial Intelligence Lab. Thanks for joining us, Alexander.
Thank you.
Tell us about this project that you're working on that essentially is using artificial intelligence for knitting designs.
So this project, the main purpose of it is to try to make knitting, especially industrial knitting, more accessible to everyday customers. The main reason is that the machines that we're working with are actually already readily available, but there is not enough knowledge of how to use them, and there is not enough software available for casual users. So we tried on one side to try to automate some of the processes. That's one of the projects where we try to use deep neural networks to infer instructions from patterns. So you take a picture of a knitted pattern, then we try to automatically figure out what are the instructions for making that pattern. And on the other side, we were investigating ways for casual users to go on websites and then from there to be able to create their own garment design or customize pre-made garments. And then we would be able to get the information that they send us and we would need it on our machine. Then eventually, if it was all working very well, then we could send that and ship it to customers.
So this is essentially software that you've created that allows this, if I understand correctly?
Yes.
And
yes, so the machines themselves, they're already existing. They've been in the market for at least 20 years. But unfortunately, the software is fully proprietary at this stage, and people don't have much knowledge about it. So it's typically software that requires a lot of skills. You need trained experts to use it. So we're trying to break that barrier and make it such that everyone would be able to access those machines.
Wow. So tell us, step us through what the consumer experience would be like with this.
So we have two different pipelines. The first one, I think the more general one, is that a user would go on our website. From there, they access our interface, and they're provided with a choice of templates for different types of garments. Then they can access the actual garments as and visualized on top of what we call the time needle bed, which is a representation of what's happening on the knitting machine over time. But it can be summarized into very simple sections that correspond to parts of your garment. So, for example, for a sweater, you would have the trunk. You can customize the size of the trunk. You can take care of the different parts, like cuffs in a glove and things like that. And so you could change the sizes if you want to make it fit your own body, or you could add patterns on top of it, and those patterns can be drawn directly as if you were using a software like Paint, where you draw pixels on top of an image. So that's one of the possible workflows. The other one is that instead of using any of those tools where you directly customize and create the patterns yourself, instead of that, you just take a picture of your garment. Currently, we can really only work with the geometry on top of a garment, not the garment itself. But then eventually what we would be able to do is that you take the picture, we get that picture into our system, then we process it, and we give you something that would be a program that would regenerate that garment for you. At this stage, we're not at the level where we can get full garments with the shape, but we can work with the patterns on top of the garments. So that's the first step in our system.
So what happens next with this, with the work that you've created here? Right now, this is a paper that's been published, right?
Yes, we have two different papers that got published. One on the machine learning side on how do you inverse the instruction from images, and the other one is more a user-centered system. But going forward, we have a few different directions. The first one is that from the machine learning perspective, we need to get more data, and data is not cheap, especially if you're interested in using very fancy types of yarns. we don't have them. So instead, we would like to be able to not use actual yarn, but really purely simulation. The trick here is that simulation data, when you have it, is very cheap, but having it requires lots of computation, so it can be very slow, especially for garments that have like millions of stitches on top of them. So we need to make that fast. And we're also interested in figuring out what are the best ways to draw garments, because currently we have our own way of doing that, but there is already a lot of professionals who are trained at doing it in different ways. So we are trying to expand our system to be able to work closer to what current professionals are doing in garment design.
So do you envision having a service or
Yes.
selling this to a company or creating your own company? What
Yes,
are the plans?
that is a possibility. It's not. It might become a startup. We're not sure at this stage. There are a few companies that are coming at the same time that might be interested in doing that. But really what we want at the end of the day is to do something similar to what has been done for 3D printing. In 3D printings, you can buy the 3D printers, but you can also send it to specific companies that will do 3D printing as a service, like Shapeways. And eventually we would like that to be available, but also for garments, so that you create your design, you send it to us, and then we ship you back the actual garment.
Very neat. And you've actually created some of these garments already, right?
Yes, so we've already created a few types of garments. They are not big enough for what people are typically interested in. I think the main type of garments that people often hear about for knitted garments are sweaters. The machines that we are working with, unfortunately, is too small for adult sweaters, but we can easily do hats or like beanies or gloves or scarves. And we are hoping to be able to access other types of machines that are kind of similar, but that have larger beds. This way we could do more interesting types of garments.
Very interesting. Is there a place people can go to learn more about what you're doing?
Yes, so we have two websites, one for each of the projects. I think the simplest one to access is deepknitting.csail.mit.edu.
It's deepknitting.csail.mit.edu.
Yes.
Great stuff. Well, we wish you lots of luck with this. MIT has certainly a great track record of helping people create startups and bring things to market.
Thank you. Yes, I hope so.
Now this. Innovation. Hi, I'm Fred Fishkin, and I've been covering consumer technology for a long time, and it takes a lot to impress me. That's why I'm excited to tell you about the latest way to enjoy cooking in the great outdoors from my friend Patrick Sherwin and his great team at GoSun Stove. What if you could harness the sun to cook your meals anywhere you go, day or night? The GoSun Fusion arrives this summer using the company's tried and true reflectors and a solar vacuum tube to get you cooking without the mess of charcoal, heavy propane tanks, or smoke. And with an optional solar panel and battery storage, and the ability to plug in at home or on the road, you really can use the GoSun Fusion to cook anytime and anywhere. Want to learn more? Head to gosun.co and use the code TEXTINATION to save 10%. That's gosun.co.